Okay, let's dive right in. We are going to dig into 5 of the biggest, most fundamental questions in all of physics. You know, the real head scratchers, the ones that keep scientists up at night.
But here's a fascinating and kind of wild thought experiment. What if these huge, seemingly separate mysteries, what if they're not separate at all? What if they're all just different symptoms of one single, underlying, and yeah, kind of strange idea about how we even look at the universe? That's the premise we're exploring today. So let's start with the very fabric of reality itself, space and time. And this first idea, well, it's a big one. It suggests our whole understanding of speed, that some things are fast and some are slow, is basically an illusion. First up, a classic, right? Can we ever break that cosmic speed limit? Science fiction absolutely loves this idea, but physics has always been like, nope, not gonna happen. The reason why, from this point of view, is truly mind-bending. Okay, this slide gets right to the heart of it. On one side, you have our everyday experience, cars, baseballs, snails, all moving at different speeds. But on the other side is this radical idea that there's only one true speed in the entire universe. So, to get this, you have to imagine reality is built on some fundamental layer. Let's call it a fabric of nature. In this view, things that seem slow to us are really just patterns moving across that fabric, kind of like a wave moving across the surface of water. The wave travels, but the water itself is just moving up and down. Our slow world is just like those waves. And here is where it gets really, really interesting. This single idea, that we're all just patterns on some fundamental layer of reality, it doesn't just explain the cosmic speed limit. No, it might also offer a stunningly simple explanation for one of the most profound puzzles in all of science. I mean, seriously, why? Why do you remember the past, but not the future? Why does a glass shatter, but never, ever unshatter on its own? This is called the arrow of time, and honestly, the fundamental laws of physics don't really have a good answer for it. Except, maybe this one does. The core idea here is that we're not separate observers just moving through time. We're actually part of the process itself. So imagine that we, you, me, this planet, are all just patterns or local shapes embedded in that fundamental fabric. From this point of view, what we call time is simply our perception of the fabric itself changing. And because we're part of that change, we can't step outside of it. We can only experience its evolution in one direction, forward. Okay, let's move on and see how this idea builds. We're going to shift our focus a bit from the nature of the universe itself to the nature of how we interact with it. And it turns out that interaction, it might just be everything. Now, this might sound like a simple question, but believe me, in quantum mechanics, this is the monster hiding under the bed. The very act of measuring a tiny quantum system seems to fundamentally change it. But what is that act? What are we actually doing when we measure something? So, according to this source, a measurement isn't a passive thing at all. It's an active division. Picture the entire universe as one single, unbroken system. To measure something, the first thing we do is we draw a line in our minds. We say, okay, this is my measurement device, and that is the rest of the universe. That very mental act of creating a distinction, of separating a part from the whole, that is the measurement. And wouldn't you know it, this powerful idea of making distinctions doesn't just solve one mystery. It also sheds a whole new light on something we totally take for granted every single day. No, really, why? Why do we measure things in meters, or kilograms, or seconds? Where do these units even come from? Are they just baked into the fabric of the universe itself? Well, in this view, the answer is a big no. Remember how we said a measurement was the act of separating a part from the whole? It's the exact same idea here. Units aren't some fundamental property of the universe. They are tools we invent by making a distinction. We take one object, like a special platinum bar they keep in Paris. We separate it from everything else, we call it a meter, and then we describe the relation of everything else to it. Units are just an invention we created for comparison. All right, for our final mystery, we're shifting from the really big philosophical stuff to something just plain eerie. It's a strange mathematical ghost that's been haunting particle physics for decades. A simple little equation that works perfectly, but for absolutely no reason anyone can figure out. It's a pattern that just seems too good to be a coincidence. This is it. Koide's formula. Now, you do not need to understand the math here, just the mystery. It's a shockingly simple equation that perfectly connects the masses of three totally different fundamental particles. The bizarre thing is, it works, but no one knows why. For years, physicists have thought it must be some deep clue to a new undiscovered theory of everything. But what if it's not a clue at all? This perspective suggests the formula is a ghost. It's a numerical coincidence that only shows up because of the way we've divided up reality to define these things we call particles. The pattern isn't a fundamental law of the universe. It's a quirk that pops out of our own definitions. It's a feature of our description of reality, not of reality itself. So let's pull this all together. We've looked at 5 huge mysteries, from the speed of light and the arrow of time all the way to some phantom equation. And strangely enough, they all seem to point in the very same direction. So here it is, the shared secret. Each and every one of these mysteries starts to dissolve when we realize it might be a product of our own perspective. The arrow of time? Well, that's just what it feels like to be a part of a changing universe, not just some spectator watching from the sidelines. Measurement and units? Those are just the lines we draw in the sand, the rules we invent to separate one thing from another. And those strange mathematical patterns? They might just be side effects of the very lines we've drawn. All of these puzzles point back to the same source, us. And that brings us to the ultimate takeaway from this whole framework. Maybe we've been looking in the wrong place all along. Maybe the biggest puzzles in physics aren't about what the universe is, but about the lines we ourselves draw right through the middle of it. And that leaves us with one final, pretty provocative thought. If the very act of separating and questioning reality is what creates these profound puzzles in the first place, what does reality look like when we're not asking any questions at all? What is the nature of that unbroken whole? That might be the biggest mystery of everything.